Kirtana, am I audible? Hello,
Yes, sir.
Kirtana, is it audible? Please let me know fast.
Yes, sir.
Kirtana, am I audible? Okay, Kirtana. Kirtana, just share my screen. Okay. So Kirtana, before going to the further, I'll just share one problem. Okay, let's try to solve this. This is the problem. This is based on the previous topic we had discussed in the last class. So can you just try to solve this one? You just try this one. 0 point. Okay, did I give this problem in the last class?
Yes, sir.
Okay, okay, then fine. So let's move to that. Okay, let me solve this one. I'm writing the solution for the previous problem. Okay, try to solve this one, Kirtan, the below one. Kirtan, are you solving this problem? The second one.
Yes, sir.
Okay, just try this one. Okay, the same way. This is also the same way. Just making difference in these two problems.
25, sir.
How much? How much, Kirtana?
25.
Not 25, Kirtana. Just try to solve it again. It's not 25. You have to calculate final temperature of the wire, right? Uh, I think you missed out the unit part, I guess. So just look at the unit part. You just missed out with the unit. That's why you are getting 25 answer. Okay? So just look at the units carefully. You will get the answer. Or maybe you are not, you didn't solve powers properly. That can also be the case. All right, Ketan, I'll just give the solution for this one. Okay. So basically, again the same formula. R2 is equals to R1 1 plus alpha delta T. Okay. You have to focus on this part because I need the temperature to be calculated. So I can simply say R2 minus R1 divided by R1 is equals to alpha delta T. So from here, this P2 is nothing but T1 plus R2 minus R1 divided by alpha. This is what the answer also you can say it looks like the question. So yeah, we can just solve this one. So so let's make all this in the red. Okay. So we can just put the values. So T2 is equals to instead of T1, I can put 20 degree because this is the initial temperature. Plus what is final R2? R2 is basically 240 minus 120 divided by the alpha. What is that? This one 2 into 10 to the power minus 4. This comes out as how much? 20 degree plus why is it not due to the flow level yeah, this increase by. So this comes out as 120 divided by 2 into 10 to the power minus 4. Any doubt to you?
No, sir.
Right? Okay. So what do you think? Everything is correct or we have missed something in the equation? There's one thing missing. Just look at this. What is that missing part? Kirtan, look at this part and let me know which variable is missing out in any of the equation.
R1.
R1,
R1,
right?
sir.
Yeah, yeah. So I just have to put the R1 over here. So this R1 will come here also. So instead of R1, I can make 120. Okay? So this will also be 120, and you can see this is cancelled out. So what I'm left with? So T2 is equals to 20 degree plus 1 by 2 into 10 to the power minus 4. So this minus 4 will come up to the top and it will be rewritten as 20 plus 10,000 divided by this. Okay. If you do this, you are going to get this. This will sum up to the 5020. You might have missed something and you made 2 by this equation is 5, so that's why you are getting 25. But that was mistake in the power calculation. Okay. So this is the solution. Degree Celsius. Okay. This is not 0, this is degree. Okay. Any doubt here, Krishna?
No, sir.
Okay. So just one more problem, last problem. After this, we'll move to the new one. Let me go to problem first. So it's used. So this is the third problem. You can just go through this. So, so if I can solve this one problem, if I have got the answer for this one,
No, sir.
okay, just try it. Like all the formulas which we have studied earlier, just go through that. Okay, the same. This will get you the answer. Okay.
So can you solve it?
Okay, Kirtana. So Kirtana, look, so the problem says, just look at that. The problem says you have to look at the number of how many electrons per second passing through a section of resistance having 20 ohm, right? What does this mean? That it says that you are given a resistance of 20, maybe 20. It, we have to calculate how many electrons are passing in a per second. We need to say, assume this resistance is nothing but a kind of conductor, right? It must be having some length and something. So it is saying that in one electron, how many electrons are passing through this particular section. This is what it is. Okay, let's see. Kirtana, if I ask you, okay, they have given you voltage, right? They are asking me how many number of electrons are passing. Can I say they're asking me what is the total number of charge in per second? If I calculate the charge, what is the charge? That is nothing but total number of electrons, right? Okay, this is what, right? Can I say that they're asking me number of electrons passing in per second? Isn't it q by time something, right? If I have something q amount, I have charge time. If I put this, I'll be getting something around number of electrons per second. Isn't it the current itself?
Yes, sir.
So can I simply say that they are asking me the current value?
Yes,
Okay,
sir.
let's show it. Like this, because look, this is number of electrons and this whole thing is going to result in the charge. But they're asking me number of electrons. So what I will do, I will just calculate the I. This I will result in this N. Okay, from here this N will come out as I by E. Is that clear? The method is clear, Kirtana?
Yes, sir.
Okay, so let's solve this. Try this. Let's put the solutions. Solution. So Q by T is equals to charge per second, right? Charge Q is equals to number of electrons. Yes. So what is current? Current is nothing but Q by T. I'm saying my time is 1 second. So NU by what is I? That is equals to V by I. 64 divided by 28. That is going to be 20. Okay, so you can simply say that you are given 3.2 ampere. What is N? 3.2 ampere divided by what is number of electrons? Electron is given. If you put the value, we are going to get charge. 1.6 into 10 to the power minus 90. Is that clear, Kirtana? So
Yes, sir.
this is 116, so it will result in 2. So this will become 2 into 10 to the power. This will go upside 90. Ampere per coulomb. Okay. Or informal, if you just go, what is this? Ampere, ampere is itself nothing but coulomb per second, right? So if you just go further, it will become as 2 into 10 to the power 90 per second. Electron per second. I hope it's clear now. Okay. So,
Yes, sir.
okay, Kirtana, so let's move to the topic itself. A new topic basically. The topic is about EMF. Okay, what is electromotive force? Have you heard of this electromotive force, Kirtana? Hello, Kirtana. Okay. So the first thing is we are going to do is electromotive. Its abbreviation can be written as EMF. Okay. Okay, so basically we have to think about any device which can supply energy continuously basically. Okay, any device which can supply energy continuously um, to flow current and so can supply energy continuously to flow current in any circuit, okay, electrical circuit is electrical circuit. Yeah, in an electrical circuit, um, are called as electromotive forces or EMF. In another words, you can say that such devices with subcapacities which transform energy from non-electrical form non-electrical form to electrical form. Okay. Okay. So, Kirtana, any idea like what can be the example of this thing? If you just look at the battery, Kirtana, can you just go through the galvanic cell? If you just look at the galvanic cell, what kind of configuration? Like I have two half cell, right? I have base kind of thing. Do I am giving any kind of electrical circuit or something? No, I'm just putting the solutions, right? So this is the chemical energy, right? Whatever the energy you are going to get it from chemical reaction, this will be a chemical energy. But at the end of the day, this chemical energy make the charges flow, electron flow in the circuit, which makes up to the current, right? Because if assume I just don't make it circuit complete, it will be acting as a it will be acting as a potential form, right? So I can simply say that it can act as an EMF because it is here what you are doing is here you are transforming the chemical energy into a one kind of electrical energy, right? So some examples you can have is a battery which transforms chemical energy to electrical energy. Another way is a generator. What generator is? You just put the fuel in the generator. What generator does is it uses the chemical energy, okay, into mechanical and then it does it to the electrical. Okay? So you can simply say that generator transforms mechanical energy to mechanical energy to electrical energy. We will discuss this some ways how we can do this part, okay, in the next basically next or two chapters. Well, basically the magnetism part. So basically we can also say that this EMF, the term used to represent the potential difference of a battery difference of a battery when no current is flowing. Okay? No current is flowing, or you can say the open circuit flowing, or you can say an open circuit. Why is talking about this open circuit? Because the moment electrons like current starts flowing, the potential will start decreasing. Okay, that's a thing. So that's why we are saying you can say the highest value of potential difference which you can have, you can say an open circuit. Okay, if you could just notice, if you have some maybe what I can say some battery based, if you have ever seen some toy cars, okay, or which are cell or battery based. So what happens is after certain time the car reduces speeds. The reason is the battery does not respond to the same potential difference which it could use to do in the newer case. Like when you get a fresh car or a new car, in that case it has a higher potential difference. Okay, so yeah, that is the thing. So open circuit across the terminals, basically across the terminals. Okay, that is the thing. Any doubt, please?
No, sir.
Okay, okay. So yeah. Now, Ketna, what happens? Till now, we have discussed about the resistance. Okay, let's talk about internal resistance of a battery. So this is the last topic for today's class. Internal resistance of a battery. Okay. Look, Ketna, if I ask you what is the resistance, so you will say resistance is nothing but ability of a conductor to oppose the motion of electrons, right? So how actually battery works? This is my battery, right? If I just complete the circuit, let's say this is something resistance and all. Okay, this is external resistance, EH. So what generally happens is some electrons are flowing. Assume this is a galvanic switch over here, right? Assume this is a bigger plate, this is a smaller plate, or you can say the anode cathode type. Okay, this is a kind of thing. So you know that in this chemical circuit, let's say I'm calling it as a division plate, basically, which divides the circuit. Okay, so let's say some electrons are there which are flowing from here to there because this is positive, so electrons are flowing in this way, right? But if you could remember, Kirtana, I told you this is a wire and this is the whole of a circuit. Whole of a circuit means to say lot of, like this is a chemical, right? And this is a another metal conductor, right? So if I say this is a conductor, this is also kind of conductor, so this is RS, right? If it has some length. Okay, it has some area. So I can say that because this is a conductor, this is a solution, it will also have some resistance to the flow of electron, right? If there is no flow of electron, it will go very rapidly. But this does not happen. Okay? Always, at least minimum resistance will always be there. So what I can say is that every battery consists of some of the internal resistance. So I can simply say that let's not make it like this circuit. Let's include a resistance, okay? A small resistance. So this is R internal. Okay. This is the internal resistance of a battery. Okay, Kirtana, just let me know if I make circuit like this, R in like this or this. Does it have any difference? Does two circuits have any difference? Just let me know this part. Like, is there any difference in these two? Okay, okay. Yeah, yeah, you can just let me know, like, is
Yes.
there any difference? No, no, yes,
Yes, sir.
no, there's no difference. Actually. We'll just get to know the reason. Okay, why there's no difference? Assume Ketana, if I just remove it, let's remove this part for now. This also. Okay. Now Ketana, assume. Now what do you think? If I put it like this, if I put it like this, what does the main thing is supposed to happen? Just electron flow, right? So if I just put it over here or over here, will its capacity will change of opposing the resistance or opposing the electrons?
No, sir.
No, right? If I ask you, Ketna, what is the potential difference across it? So you will say, sir, like this plate has zero, okay? Like this because if I just look at this, what is the potential difference across this? You can simply say, sir, this terminal of the resistance has V. Assume this is a V battery. This terminal is zero. So what is the potential difference across this? You will say, sir, V. Here, let's look at this terminal contains zero, right? And this terminal contains V. So if I again ask you what is the potential difference, you can say V minus zero. So again, it's so you can say that it does not have any difference. Right? Okay, that is. I have just removed the second resistance because we have not studied the combination of resistance till now. But I know, like as per your grade 10, you must have some basic idea about this. Okay, so basically what happens is, in general, battery transforms chemical energy to electrical energy, right? Okay, so how it is like, assume this is a going circuit. This is terminal A of a battery. This is terminal B of a battery. Okay, and it will like this. And this is an internal battery. Okay. The circuit is like this chemical connection. So this is because there is a transferring of the electron. So this will be acting as a resistance. So it's not exactly like this, but you can just think of something. So this is R internal. Okay. Basic, what does this mean by R internal? Internal resistance of the battery. Internal resistance of battery or resistance offered by the chemical composition of battery. Any doubt you feel? No?
No, sir.
Okay. So basically, in electrical circuit, you can just consider this in the series. Okay? Series means to say in circuit, this R internal comes in series with series with battery. Okay. So basically, take note what happens. So assume this is a whole of the circuit, bigger circuit. Okay. So when electrons are passing, it is an open, right? But when it goes inside, there's a chemical, right? That's okay. So because in there, in these conductors, there's a lot of free space, okay? But in chemical, it is not. So the mobility of the electrons are as not same as in case of outside in the conductor or inside the chemical composition. Okay? So you can simply say that this chemical composition reduces its mobility. Due to that, it is like its speed gets decreased, something happens. You can say that it provides a resistance. Okay, so you can simply say this is A, this is RA, and this is a bed. Okay. That is the three phase now. Any doubt? Extended to the circuit, extended to the circuit. That is the thing. This is all for the today's class later. If you have any doubts, just let me know, or else we can have the session by this.
No doubts.
Alright, alright. So I can just end the session by this, okay? Good.